Hi there, in this video we're going to go over a quick review of the properties of the Fourier Transform, which we've covered in the last several videos. So let's split this into two. So on this side we'll have our time, and on this side we'll have our frequency. Okay, now first thing we looked at, well, first of all we'll write down the Fourier Transform. So we generate f of t by doing the integral from minus infinity to infinity of times 1 upon 2 pi of our function f of j omega e to the plus j omega t. Okay, so that's the inverse transform, and we can get our f of j omega as integral from minus infinity to infinity over f of t a to the j minus j omega t. Okay, so that's our inverse transform. Now the first thing we looked at was linearity. Oh, right, it's getting a bit crazy. Linearity. This really just told us if we had a function in the time domain, we multiplied it by some constant a, and another function in the time domain f2, and we multiplied it by another constant a2, then in the frequency domain it'd be equivalent to multiplying a1 with the Fourier transform of the first one, f1 of t, and a2 times the Fourier transform of f2 of j omega. Okay, so the next one we looked at was the scaling. The scaling told us that if we had some function f of t and we scaled the axis by some real number a, then in the frequency domain the equivalent to changing the magnitude of the function by 1 upon the modulus of a times the Fourier transform of the original function, but with the frequency divided by a. Okay, and also in the frequency domain this can be written as the Fourier transform of some function j omega, but it's been scaled by some factor b. Then in the time domain we have the magnitude is decreased by 1 upon modulus of b, and the frequency is changed by a factor of, the time domain is changed by a factor of b. Okay, so that's the, I should put little lines like that so that we're going back and forward. Okay. Okay. Now, next we looked at the duality. Now, the duality told us that some function f of jt would give us another function in the frequency domain 2 pi f of minus j omega, and in the time domain we could say 2 pi f of minus t, and the frequency domain would give us a value f j omega. Okay, then we had a look at the shifting property. in the shifting property, we had a function of time and we delayed it by some value t0, and the frequency domain is equivalent to changing the phase by amount e to the j omega t0 times f of j omega, and the same in the frequency domain. If we were to have some function in frequency and it's been delayed by some factor omega naught, and the time domain, it's equivalent to taking the time domain function and giving it a phase shift by j omega naught t. Okay, so that's another couple of our pairs. Now we looked at convolution in time and frequency. Convolution, if we convolve two functions in the time domain, it's equivalent to multiplying their equivalents in the frequency domain. And that would be g. I'll get a rubber there, I don't want to cause any confusion. Okay, so that's going to be g of j omega, and again in the frequency domain, if you had it was 1 upon 2 pi f of j omega, and if we were to convolve that with g of j omega in the time domain, we get our function of time times the g of t. Okay. Okay, so next we looked at differentiation. Differentiation, and we've seen that if we were to take the nth derivative of some function f of t by dt, then in the frequency domain it's equivalent to taking the Fourier transform of the function f of j omega and multiplying it by j omega raised to the power of n. And equivalently, in the frequency domain, if we took a function of frequency j omega and we raised it to the power of the nth derivative by d omega, then we'll get our original function f of t times minus j t raised to the power of n. Okay. And then we looked at integration. And we've seen that if we were to integrate a function from minus infinity to an upper limit t of the function f of t by dt, then that's equivalent in the frequency domain of multiplying the original function by 1 upon j omega and adding on a dc term or a constant term delta omega at f naught. Okay. Then we looked at the Fourier transform of sine. So I'll just put in sine, and we've seen the Fourier transform of the function sine omega naught t gave us minus j pi delta omega minus omega naught plus j pi delta omega plus omega naught. Okay, and the next one was the cosine, so I'll just put sine slash cosine. Okay, so the cosine told us cos omega naught t was equal to pi delta omega minus omega naught plus pi delta omega plus omega naught. Okay, and finally I'll have to go into the second page for just as the last one. I almost squeezed them in there. Right, so finally we looked at convolution with shifted impulse, so I'll just put shifted impulse. Okay, the convolution with a shifted impulse told us that a function f of t minus t naught equals delta t minus t naught convolved with f of t. Okay, and also in the frequency domain, if I write it down here, told us that if we had our well, I suppose we should keep it at the other side because that's what the intention was, to keep time at one side and frequency at another. Okay, so it could also be written in the frequency domain as f of j omega minus j omega naught is equivalent to the shifted impulse delta j omega minus j omega naught convolved with f of j omega. Okay, so that's our frequency and that's our time. Okay, so that's everything that we have looked at so far. Now there are other things that we could potentially look at, in fact, but that'll do for now. It's a good little place to kind of stop. And the interesting thing about all these equations is that if you were to look at them straight off, you know, they look quite incomprehensible, but every single one of them can be comprehended in terms of really a two-dimension or are drawn in 3 dimensions. Okay, so I mean, human beings live in 3 dimensions, so it should be easy enough for us to try and comprehend things in 3 dimensions. That's how we live. Okay, so anyway, that's all for now. We'll have a little break there, and the next video I'll go on, I'll just have a general chat about what we've done so far, and have a look at some of the books that I've used over the years, and then after that we'll move on to the next set of videos, which will be on the Laplace transform. Okay, thank you for listening, and goodbye.